The world of AI is just, well, it's moving incredibly fast, isn't it?
It really is. Feels like every week there's something new.
Exactly. One moment we're talking about, conversational giants like ChatGPT writing amazing text, and the next it's stable diffusion creating these unbelievable images.
Or Sora generating video scenes just from a prompt.
Right. But if you look closely, these powerful AIs often have these really intricate, very specialized designs. Each one is kind of built for its own thing.
Like different tools for different jobs. Very effective, but separate.
Yeah, like having a master painter, a master sculptor, master composer,
Yeah.
all separate experts.
Mm-hmm.
Now, what if you had one artist who could do all of that? Painting, sculpting, composing, all with like one core method.
Okay, I see where you're going.
That's basically the idea we're diving into today. We're looking at a model called Emu3, and it's trying something, well, really bold, I think.
Definitely bold.
It's trying to do all of it, language, images, and video, using just one fundamental sort of unified approach.
That's the core of it. And our mission today really is to understand how Emu3 manages to get, state-of-the-art results across all these different areas.
So what's the secret?
Well, the key idea seems to be tokenizing everything.
Yeah.
Putting it all into what they call the discrete space. And then this is the crucial part, using a single transformer model.
Just one.
Just one. And it relies purely on next token prediction. So we're going to unpack how this approach could, radically simplify how complex multimodal models are built.
And what that simplification might mean for the future of AI overall.
Exactly. Big implications.
And just so everyone knows where this is coming from, our deep dive today is based squarely on a pretty exciting research paper. It's titled Emu3, Next Token Prediction is All You Need.
Right, and that's from the Emu3 team at BAAI. So this is straight from the researchers themselves.
Cutting edge stuff. Okay, so let's peel back the layers here. The big idea. Next token prediction. Many of us probably get the basics of this from language models, right?
Mm-hmm. Yeah, it's like predicting the next word.
Yeah. Like you type the quick brown fox jumps over the lazy, and the model predicts dog. Simple concept, very powerful for text.
Right. But here's where Emu3 gets really, really interesting. It takes that same simple idea and applies it to everything. Text, images, videos.
How does that even work for images and video? They seem so different from text.
Well, that's the clever bit. It tokenizes everything into a discrete space. So think of it like this. Text gets broken into words or word parts, right?
Yeah.
Emu3 does something similar for images and videos. It breaks them down into fundamental visual tokens. It's almost like turning pixels or image patches into meaningful building blocks with their own IDs.
So like a vocabulary, but for visuals.
Exactly.
Yeah.
A visual vocabulary. And because everything, text tokens, visual tokens, is in this common format, a single transformer model can be trained on a mix of all these sequences.
Okay. So the model just learns to predict the next token. And it doesn't really care if that token represents a word or part of an image or a video frame.
Precisely. It learns the patterns across all modalities, all at once, trained completely from scratch on this mixed data. It allows the model to handle all data types uniformly. Super efficient, potentially.
That feels like a really big departure from, well, what we usually see. We have amazing diffusion models like stable diffusion for images or Sora for video.
Which are incredibly powerful, no doubt.
But they are highly specialized, right? And often pretty complex under the hood. And then you have vision language models that sort of stitch things together, like using CLIP for vision and then feeding that into an LLM.
Yeah, combining different pre-existing modules.
So Emu3 is basically saying, maybe we don't need all that complexity. Maybe we don't need these separate specialized designs.
That seems to be the core argument.
Yeah.
Simplify the whole process down to this one core mechanic. Next token prediction.
So it's not just about making things, I don't know, tidier. This could actually change how we build AI systems, couldn't it? Maybe make innovation faster if you don't need separate teams for each modality.
I think that's exactly the hope. This convergence on just focusing on tokens. It has huge potential for simplification, instead of a whole toolbox of specialized models.
You have one universal translator.
Kind of, yeah. A universal interpreter for all sorts of digital information. And the paper argues this isn't just, like, theoretically neat. They claim it unlocks real potential for scaling up, both in training the models and using them for inference, towards a more unified and maybe more efficient AI.
Okay, that unified approach, next token prediction for everything, sounds very powerful in theory, but let's get practical. What can Emu3 actually do? How good is the stuff it creates?
Yeah, good question. And the answer seems to be remarkably good. Let's start with image generation. The paper claims state-of-the-art performance,
Better than the big names.
while they highlight it surpassing Stable Diffusion XL, SDXL in human evaluations, which is a pretty big deal.
Oh, okay.
And it also does really well on a bunch of standard benchmarks. Things like MSSOCO 30K, Genevol, T2I Comp Bench, DPG Bench. These are all established ways to test how well models generate images based on text.
And what do the images actually look like? Any cool examples?
Yeah, the paper shows some really diverse stuff, like a serene winter landscape inside an ornate picture frame.
Mm.
Or get this, a whimsical meerkat wearing a Baroque dress.
A meerkat in a Baroque dress. I love it. That's exactly the kind of creative weirdness AI should enable.
Right. Or a happy corgi on a swing, or even like two pirate ships battling it out on a sea that looks like frothy coffee.
Okay, that's imagination. And it handles different styles and resolutions well.
Seems so.
Yeah.
Flexible resolutions, different aspect ratios, different styles. And they didn't stop there. They also refined the images using something called direct preference optimization, or DPO.
EPO, right.
Oh.
That involves human feedback, doesn't it?
Exactly. Humans basically look at generated images and pick the ones they like best, or reject the worst ones based on the prompt.
And that feedback goes directly back into tuning the model.
Yep. It directly fine-tunes the model based on those preferences. The idea is to improve the visual quality, sure, but also to make the images align better with what the user actually asked for in the prompt.
Makes sense. Better alignment, more useful results. Okay, so images are strong. What about video? He said it handles video too.
It does, and again, using that same next token prediction core.
Mm.
So natively, it can generate 5-second videos at 24 frames per second.
5 seconds. Okay.
But here's the really neat part. Because it's autoregressive, meaning it predicts token by token, or frame by frame in this context, it can theoretically be infinitely extended.
So it can keep predicting the next frame based on the previous one.
Precisely, you can just keep it going.
Yeah.
And performance-wise, they benchmarked it against open-source text-to-video models using VBench.
Which tests video quality specifically.
Right, and Emu3 apparently outperforms the majority of them. The paper shows examples like an astronaut flying, but in a cyberpunk style, or really fiery lava flowing down a mountain, or just, realistic beach waves.
So it can simulate environments, people, animals.
Seems like it. Simulating aspects of the physical world dynamically.
That's impressive. A real creative powerhouse for both images and video then. But AI isn't just about making stuff, is it? Understanding the world is maybe even more important. How does Emu3 do on, comprehension tasks?
Yeah, that's a critical piece. And what's really fascinating here is how it handles vision language understanding. They describe it as a pure encoder-free method.
Encoder-free, meaning?
Meaning it doesn't rely on separate specialized bits, like a dedicated language model just for text, or a specific vision encoder like CLAP to process the images first.
It just uses the single transformer for understanding, too.
That's the claim. Despite this, simpler, more unified architecture, it apparently holds its own against, or even beats, established models like LLaVI 1.6 on several benchmarks.
Which benchmarks are we talking about?
Things like Seed Bench, which covers a lot of different vision language tasks, OCR Bench for reading text in images, and Real World QA, which is about answering questions based on real-world images.
Okay, so what can it actually understand? Can you give me an example?
Sure. So it could accurately describe a complex photo, like one of the Brooklyn Bridge. Or it could look at an image containing a mathematical formula.
Like in a textbook picture.
Yeah, exactly. And it could transcribe that formula directly into the LaTeX format, which is pretty useful.
Wow, okay. That requires some detailed understanding.
Definitely. Or even analyze, say, a diagram of a food chain and predict what might happen if the phytoplankton levels changed.
So, reasoning based on visual information.
Seems like it. They even show it providing really detailed descriptions of magazine covers, pointing out all the different visual things in the text on the cover.
That's pretty sophisticated understanding, especially coming from a unified model without all those extra specialized parts. But, okay, maybe the wildest thing you mentioned earlier was the future prediction for videos. That still kind of blows my mind.
It's pretty mind-bending, yeah. If you connect this back to the core idea.
Yeah.
Because it's always predicting the next token, which could be the next frame.
It can essentially predict what happens next in a video.
That's the capability. It can take an existing video clip and extend it by predicting the subsequent frames. The paper shows examples using just a 2-second clip as context.
And predicting what?
Predicting the next 2 seconds. And even more impressively, they showed it's possible to extend a video by 8 seconds using only the initial 2 seconds of data.
8 seconds from 2. What kind of things can it predict?
all sorts. Predicting human actions, like someone continuing to ride a unicycle down a street based on a short starting clip. Animal actions, how objects might interact in the real world. Even predicting how, like, a 3D animation might continue to rule. They showed an example of predicting smoke continuing to rise from a cartoon chimney.
That feels like more than just pattern matching. It's almost like it has some basic understanding of physics or causality.
It certainly hints at that direction, doesn't it? This ability to simulate aspects of the physical world, even in a limited way, is a really significant step. Think about the implications for things like robotics, or creating much more realistic interactive simulations.
Absolutely. Okay, so let's sort of wrap our heads around this. We've taken this deep dive into Emu3. It's this pretty groundbreaking multimodal AI.
Definitely feels like it.
And its whole philosophy is simplifying things down to one core principle: next token prediction.
For everything: text, images, video generation, and understanding.
And it seems to be challenging the big players, the established leaders in image generation, video generation, vision language tasks, all without needing those complex diffusion models or stitching different models together.
Yeah, it avoids those traditional compositional approaches. But, whenever a model claims it can do everything with just one simple trick, you have to wonder, are there trade-offs?
That's what I was thinking. Like, are there specific situations where a super specialized model, like a diffusion model just for images, might still be better? Or maybe this unified approach is less efficient for certain specific tasks?
That's a fair question, and the paper doesn't necessarily claim it beats everything in every single metric.
Right.
But it provides really compelling evidence, I think, that this next token prediction idea can be a genuinely powerful and scalable way to build multimodal AI.
So maybe not perfect yet, but a strong proof of concept.
A very strong one. It suggests we really are getting closer to a more general kind of multimodal intelligence,
Yeah.
moving beyond AI that just understands language towards something more integrated.
Which is huge. So for you listening, this isn't just about, some technical details under the hood.
Not at all.
It really makes you think, what kinds of new creative tools does this unlock? What real-world problems could be tackled differently if you had an AI that understands and generates across modalities so seamlessly?
Imagine, like, an AI that could generate an entire movie scene just from a script snippet,
Oh.
but then also anticipate where the plot might go next, or react dynamically to visual changes within the scene it just generated.
All based on that single unified understanding.
Potentially, yeah. Or an AI that could truly understand physics in a simulated world well enough to interact realistically.
Yeah.
Well, it definitely gives us a lot to chew on, doesn't it?
It certainly does. A glimpse into a potentially very different future for AI.